In this lesson, we will discuss a new set of identities called the sum and difference identities, and another related set of identities called the double angle identities. The double angle identities are just going to be a special case of the sum and difference identities. And the sum and difference identities are basically identities or formulas, if you so will, just think about them that way, that allow you to expand a trigonometric function whenever you have either a sum or a difference inside. And these formulas, of course, they don't come from the sky, they don't come from heaven. They are true. I'm not going to go into the details of why they are true. Most people don't really need to know why they are true, they just need to know how to use them. If you're a math major, though, you should probably look up why they're true. But if you're not a math major, then you don't have to worry about it. So just learn how to use them. And you don't have to memorize these formulas either. Okay, so here's the first one. It says cosine of x plus y equals cosine of x, cosine of y minus sine of x, sine of y. So you see, it allows you to expand a cosine if you have a sum. So what this formula is telling you is that, first of all, it is not true that if you have a sum inside a cosine, it is not true that this is cosine of x plus cosine of y. You cannot do that, right? That is false. The way you expand this is, the left-hand side is by using this formula. So the cosine of x plus y is what? It is cosine of x, cosine of y, minus, and note that the sign changes. If you have here a plus, that's a minus. So minus sine of x, sine of y. The formula, if you have a minus inside, is essentially the same. If you have, with the difference being, if you have, right, if you start out with a minus inside, then this is going to be a plus. But everything else is the same. Cosine of x minus y is going to be equal to cosine of x, cosine of y, plus sine of x, sine of y. And actually, the second formula is a derivative or a special case of the first one. And that's because if you have x minus y, you see you can change that minus to a plus and say this is x plus negative y. And then you can use the formula for sum. And if you use the formula for sum, what do you get? You get cosine of x, cosine of negative y, minus sine of x, sine of negative y. But then we know that cosine is even, so you can drop this negative from there. And we also know that sine is odd, so that means you can bring that negative to the front here. And then you would have two negatives, which becomes a positive. You would have sine of x, sine of y, and you see that's precisely the second formula. Cosine of x minus y equals cosine of x, cosine of y, plus sine of x, sine of y. So the second formula is actually just a special case of the first one, or can be obtained or derived from the first one. Both of these formulas are usually just abbreviated into a single formula written like this. Cosine of x plus or minus y equals cosine of x, cosine of y minus plus sine of x, sine of y. And you see the signs are here inverted. And what that means is that if this one is positive, then this one is negative. And if this one is negative, then that one is positive because they are opposites. You see they are inverted. So that's one way of simplifying both formulas into one. Now there's also a sum and difference formulas for sine, and here are the formulas. Again, you don't have to memorize these, and unless you're a math major. If you're a math major, you probably should. Okay, so here are the formulas. Sine of x plus y equals sine of x cosine of y plus sine of y cosine of x. The formula for the difference of two angles is exactly the same. The only thing that basically changes are the signs. If in the case of sine, if you start with a plus, you're gonna get a plus on this side, and if you start with a minus, you're gonna have a minus on this side. And both can be condensed into a single formula by writing plus or minus, plus or minus. In this case, note that it's plus or minus exactly the same on both sides, and what that tells you is that if this is a plus, that's a plus, and if this is a minus, that's a minus, because it's exactly the same symbol. You see, it's not like backwards like here or upside down. That means it's a different symbol. So if this is a plus, that's a minus. If that's a minus, it's a plus. Here is the exact same symbol. So that means, again, that they should be the same. And lastly, there is the sum and difference formulas for tangent. And these formulas come directly from the ones above, because tangent is sine over cosine. I'm not going to do the derivation, but if you write tangent equals sine over cosine and you use these formulas and do a little bit of algebra manipulation to simplify it, you end up with these formulas right here. Okay, so that's where these ones come from. And say the following. Tangent of x plus y equals tangent of x plus tangent of y, all that over 1 minus tangent of x times tangent of y. The formula for the difference is similar, just the signs are different, and then you can simplify them or condense them into a single one by saying tangent of x plus or minus y equals tangent of x plus or minus tangent of y, and then all that over 1 minus plus tangent of x tangent of y. So that means if I start here with a plus, the top is going to be a plus, the bottom is going to be a minus. If I start out with a minus, the top is going to be a minus and the bottom is going to be a plus, because the symbols are inverted. On the top is the same, on the bottom it's inverted. Okay, good news is these formulas are rather easy to use. Let's start with the following example. So this is like a standard application of the sum and difference identities. So it says find the exact value of sine of 15 degrees. Remember that when you say find the exact value, it means no decimals, no calculators for figuring out the value of sine of 15. We're going to use only special angles. So this is how this is done. You see, 15 degrees is not a special angle. However, it is the difference of two special angles. It is the difference of two special angles. In fact, it is 45 minus 30. So that's what you are required to notice here. That sine of 15 degrees is sine of 45 minus 30 degrees. Now, we just use, now that we rewrite it like that, we're just going to use the formula for the difference of two angles for sine, and we're going to get this is the same as sine of 45 degrees cosine of 30 degrees minus sine of 30 degrees cosine of 45 degrees. Okay, that's what we get by just applying the formula. And now these are special angles. Those you're supposed to know by heart, know by memory. And just write down what we get. Let's see. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is a half. And cosine of 45 degrees is square root of 2 over 2. So then simplifying, this is multiplying across the tops. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4 on bottom. And on top, 1 times square root of 2 is square root of 2. And 2 times 2 is 4 on bottom. And now we have a difference here of two fractions that have the same denominator. So we can just write it down as a single fraction. And that's it. That's simplified. So what that means is that sine of 15 degrees, which is the same as this, of course, equals square root of 6 minus square root of 2 over 4. Okay, so the key idea for solving this problem was to try to come up with a combination of special angles that when you either add them or subtract them, you get the angle given to you. So in this case, I wanted to get 15. So you have to think of two angles that are special angles so that when you either add them or subtract them, you get 15. And 45 and 30 worked, was the combination here. Sometimes you may have more than one combination that works, but just choose one that you can use. So for example, you could have used 60 and 45. Actually, that would have worked just as well. 60 minus 45 also gives you 15 degrees. And that would have been another way of doing that problem. Here's another one. It says, use the sum and difference identities to find the exact value of 135. So again, you just have to think of one combination that works. Two special angles that when you either add them or subtract them, you get 135. In this one, you could use, for example, 180 minus 45. 180 minus 45 gives you 135. So that will work. I already used the difference, so I'm going to use the sum now just to change it up. So 90 plus 45 also gives me 135, so I'm going to use that one. So we can say cosine of 135 is the same as cosine of 90 plus 45. Okay, that's one combination that works. And then all we have to do is apply the formula for the cosine of a sum of angles. So you can look this one up. And it is this one right here. So okay, so what do we get? We get cosine of 90, cosine of 45 minus sine of 90, sine of 45 degrees. Okay, these are special angles. We should know what these are off the top of our heads. Okay, so cosine of 90 degrees is 0. Cosine of 45 degrees is square root of 2 over 2. Sine of 90 degrees is 1. And sine of 45 degrees is square root of 2 over 2. Simplifying, 0 times that, well, that's just 0. That just goes away. And then multiplying times 1 doesn't do anything, so this is negative square root of 2 over 2. And that's it. Okay, like I said, that's just one way of doing it because you could have used another combination such as 180 minus 45 degrees. Alright, let's do another one. Sometimes they will give you the problem in terms of radians, like this one. It's done exactly the same way, although the right combination that gives you the angle inside might not be as immediately obvious. You might have to like play around a little bit with it before you get to the right combination. But if you have something like 5 pi over 12, well, thirds and fourths should probably come to mind, or either sixths and halves. So that could work. So let's see. One combination is 5 pi over 2 minus, pi over 2 minus pi over 6. I think that could work. I'm not sure, but let's check. Okay, this is how you do it. If you think that that's a possible combination, just check. Alright, so multiply by 6 top and bottom, you will get 6 pi over 12 minus pi over, and then you have to multiply this one by, okay, let's do that again. Multiply this one by 3 and by 3, you will get 3 pi over 6 minus pi over 6 equals 2 pi over 6. Whoops, well, that does not work. That does not work. That was bad. So what else can you try? You can try pi over 4 and pi over 3. Let's try that one. Multiplying this one by 3 and by 3, you will get 3 pi over 12. And multiplying this one by 4 and by 4, you will get 4 pi over 12. And that gives you 7 pi over 12. Okay, that overshot it. So neither of these is the one. So what in the world? What is it? Let's see. Pi over 4 plus pi over 6. Let's try that one. We multiply by 3 and by 3, you're going to get 3 pi over 12. And then this one times 2 and times 2, that would be 2 pi over 12. Aha! Bingo! So this is the combination that works. Okay, so I went through all of these instead of just telling you to show you that, you see, this, when you have radians, that's not so obvious, and you just have to try different combinations to see which one is the one that works. Oops, and that should have been a 2, by the way. Okay. Alright, so now we know that 5 pi over 12 is pi over 4 plus pi over 6. Okay, let's use that now. So, tangent of 5 pi over 12 breaks up as pi over 4 plus pi over 6. And now what we have is a sum inside a tangent. So now you look up the formula. A sum inside a tangent, and that's the formula. So let's use it. So this is going to be tangent of pi over 4 plus tangent of pi over 6, all that over 1 minus tangent of pi over 4 tangent of pi over 6. Okay. And now, these are special angles. You can just write down now what they are. Okay, you're supposed to know these ones by heart, or from a table of values that you can just write down real quick to figure it out. The tangent of pi over 4 is just 1. Tangent of pi over 6, that's just square root of 3 over 3. And then tangent of pi over 4 is 1. And tangent of pi over 6 is square root of 3 over 3. And of course, you don't leave it like that because that's not simplified. You have fractions over fractions. So let's simplify it. First, multiplying by 1 doesn't do anything. So on the bottom, it's the same as having 1 minus square root of 3 over 3. And now, if you multiply top and bottom by 3, that's going to get rid of that 3. Remember, that's a trick you learn in college algebra. To simplify a complex fraction like this one, we have fractions over fractions. You just multiply by the LCD of the little denominators that you see. I only see one little denominator, 3, so I multiply by 3 top and bottom. When you distribute this one here, you would get 3 plus square root of 3, all that over, distribute here, you would get 3 minus square root of 3. And that's the end. Okay. Now another type of exercise that you could have using these formulas is to simplify an expression like this. So it says, use the sum and difference identities to find the exact value of that. Okay. Well, you see these combinations in sines and cosines, and the idea is that that really looks like one of the combinations that appears in one of the sum and difference formulas. So our job is to find which one. So I see a cosine times cosine, then plus sine times sine. So you just have to match it. In the one that is cosine times cosine plus sine times sine, which is what I have right here, cosine times cosine, sine times sine, is this one right here. So the formula tells me that that is equal to cosine of the difference of those angles. Okay, so that means this is then equal to cosine of the difference of this angle. That's what the formula tells me. Okay, and then let's simplify this. What is this? This is cosine of 30 degrees. 41 minus 11 is 30. And then we know what that is. That's a special angle. This is square root of 3 over 2. There you go. So that's the end. You see, we were able to figure out the exact value of that without even knowing what is cosine of 41. I don't know what cosine of 41 is. That's not a special angle. Or knowing cosine of 11, I don't know what that is. Sine of 41, I don't know what that is. Sine of 11, again, I don't know what any of these are because none of these are special angles. But still, using the sum and difference identities, we were able to figure out the exact value nonetheless. So that's one utility of these formulas. Okay, let's try this one. See if you can match. Take a moment, pause the video, and try to match these two expressions to the corresponding sum and difference identities and see if you can simplify it all the way to get an exact answer. Okay, assuming that you did that, see if you get the same thing as me. So I have here a sine, 88 cosine, then cosine sine. So in other words, I have a sine times that cosine, and so let's see, sine times cosine. Okay, looks like we're in here. It's one of these two. So which one is it? And I have a minus in the middle. So it has to be this one. Yeah. Sine of x cosine of y. So sine of one angle, cosine of the other angle, minus sine of the other angle, cosine of the other angle. You see the order here is a little bit different, but actually doesn't matter because when you're multiplying things, the order does not matter here. So that means that this is actually the same as sine of 88 cosine of 28 minus sine of 28 degrees cosine of 88. Okay, so pay attention to that. It could be slightly different, but it's the same thing. So sine times cosine, that one is this one, alright? So it is, either way, it is the difference, it is the sine of the difference of the angles. The first, the x is the sine of whatever I had first, so it's going to be the 88, and then the other angle is the 28. So this is the difference, the sine of the difference of 88 minus 28. Okay, just matching numbers to the formula. Now what is this? This is sine of 60 degrees. And sine of 60 degrees is, we know that one, this is square root of 3 over 2. And that finishes the problem. Okay, and let's do the last one. The last one is definitely one of the tangent formulas. Again, there's only two. This one has a minus on top and a plus on bottom. Minus on top, plus on bottom is a difference. Then it's a difference. Tangent of the difference. And you take them in the same order. So tangent of x minus tangent of y. So the x and the y, they are in the same order. So that means in this one, this should be tangent of the difference in the same order, according to the formula, 7 pi over 12 minus 11 pi over 12. Okay? And now let's simplify this. 7, because they have the same denominator, we can just subtract the tops. 7 minus 11 is negative 4, so this is the same as tangent of negative 4 pi over 12. You can cancel a 4 from both numerator and denominator, and that's going to give you, so canceling a 4, negative pi over 3. Tangent is odd, is an odd function, so you can bring out the negative to the front. So this becomes negative tangent of pi over 3. And now that's a special angle that value we know off the top of our heads because we memorized it, or because you can figure it out real quickly by writing tangent is sine over cosine. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is a half, and simplifying that. Either way, you're going to get that this is square root of 3. Tangent of 60 degrees is square root of 3. So, we're done. Alright, now, if the result that you get after applying the formula is not a special angle, such as here, pi over 3, or 60 degrees, or 30 degrees, if it's not a special angle, then you just leave it like that. Okay? So, for example, here, it says, same problem, so do exactly the same thing, we're just not going to get a special angle. So for example, this one, cosine times cosine, sine times sine, matching this one, it's this one, cosine, cosine, sine, sine. It's a sum inside a cosine, okay? So matching this one, that's a sum inside the cosine. So this is cosine of 21 degrees plus 10 degrees. And simplifying, this is cosine of 31 degrees. That's not a special angle, so we just leave it like that. Okay, we just simplified the whole thing to a single cosine. Okay, that's it. Try B and C. See if you can simplify those all the way by matching them to the corresponding sum or difference identity. Okay, assuming that you just did that, let's compare notes. The first one is sine times cosine. cosine times sine. Again, I said, remember that the order here does not matter. So the important thing is a product of a sine and a cosine, a plus and a sine times a cosine. So matching that, that should be this one. So is a sum inside a sine. Okay, so in other words, this is the sum of the angles inside the sine. Okay, there you go. Now let's simplify it a little bit more before we declare it over. These are fractions that have different denominators. Then the least common denominator is 10. So the first fraction stays the same. The next one, you multiply top and bottom by 2. So the top becomes 4 pi. And then now you can add across the numerator. 7 plus 4 is 11. So 11 pi over 10. That's not a special angle. It's going to stay like that. That's the simplification. And of course, you could do this even if you had variables. Like in the next example, it says tangent of 7x plus tangent of 3x, all that over 1 minus tangent of 7x tangent of 3x. Well, you recognize that as one of the sum or difference formulas for tangent, and it looks most like the first one on top. It's a plus and a minus on bottom. You have something, something else, and then in the same order, you have the same thing. So is a sum inside a tangent. So simplifying then, this is equal to the sum of those two angles inside the tangent. So 7x plus 3x. And simplifying that, that is just tangent of 10x. That's the end.